and the limited number of days before you leave on senior trip, which means we have our tests before that, you'll need to keep on top of things. So don't get so excited about graduation that you forget you need to graduate. You need to pass so that you can graduate. All right, determinants. Matrices that are square have a value that is called a determinant. And if I have a 2 by 2 matrix, or they say order 2, so these have to be square matrices, a 2 by 2 matrix, well, we find that determinant, we put straight lines around it. Notice back here it has matrix A with these straight lines around it. They look kind of like absolute value. We've used that before. Well, with matrices, they stand for determinant. And we are going to multiply the numbers in this diagonal. So they say A sub 11 times A sub 22 minus the product multiplying the numbers in this diagonal right over here. And that gives us the value of the determinant on a 2 by 2 matrix. Extremely simple. You just need to remember how to do it. So if I want the determinant of this matrix A, I'm going to take 5 times negative 3. I'll write down the steps on this one. Whoa, kind of bumped my board. 5 times negative 3 minus, and it's always minus, and then it is 2 times A3. So this will be negative 15 minus 6 more equals negative 21. There's the determinant. So the math is easy. You just need to know what do I do to find a determinant of a 2 by 2. That's all you do. Evaluating determinants by expanding with cofactors. When we get larger than a 2 by 2 matrix, it's not a simple formula to find the determinant. We have to do another formula. So we're going to take a 2-step process on learning how to find determinants of larger square matrices, such as this matrix right here, which is a 3 by 3 matrix. The first thing we need to do is find what is called a cofactor. Now, they have given you the formula right here, which doesn't mean a lot to us right now. They have A rho sub 1 times cofactor rho sub 1 plus A rho sub 2 times cofactor rho sub 2, etc. It doesn't mean a whole lot to us yet. But that's what we're going to be using right up there. So let's come down here and let's see if we can do this. If I'm going to find the determinant, we can expand by the cofactors, which we'll learn how to get, of any row or column in this matrix. So right down here, they are saying the example of, let's take row 2. We could have taken row 1, 2, 3, or column 1, 2, 3. So there are actually 6 different ways we can find the determinant. It's always the same number. So how do we do that? Well, I take the first value in my row, 4, times the cofactor that goes with it. Now, this is cofactor 21. That means row 2, column 1. It's the cofactor that goes with that 4. We'll learn how to get it. Plus negative 2, the next number in the row, times the cofactor that goes with it, plus 3 times the cofactor that goes with that one. So that's what we mean by expanding. We're going to use the numbers in a row or a column, and it doesn't matter which one. Now, what we do next, notice here, is the 4, the negative 2, and the 3 that we have seen already. So how do I get this cofactor? Well, the first thing I do, a cofactor is made up of 2 parts. They have now taken this cofactor sub 21 and said, hey, it's negative 1 raised to the, and how do I get the 2 plus 1? It's the sum of the 2 and the 1, row 2, column 1. We take negative 1 raised to the power of the position of this 4. It's in row 2, column 1. So that would be negative 1 to the 3rd power. Times the minor that goes with that position. And now here's the first thing where we figure out how to do some work. The minor 21 means I cross out the row 2 and the column 1, and what is left? 3, negative 1, negative 3, 4. 3, negative 1, negative 3, 4. What is left is a 2 by 2 matrix that I find the determinant of. And that's the pattern we keep going with. So this negative 2, let me change colors to red. This negative 2, which is found right here, when I take it times its minor, I cross off the row and the column that the negative 2 is on, 2, negative 1, 2, negative 1, 1, 4, 1, 4. There's the minor that goes with it. And that is a little 2 by 2 determinant, etc. We follow that pattern. So they went ahead and simplified this all out, and they said, hey, we ended up getting a determinant of negative 27 for this 3 by 3 matrix. So let's try it. Evaluate a determinant by expanding by cofactors. All right, so we want to find the determinant of this matrix. I can take any row or I can take any column and expand. I am going to choose row 3, or I might have chosen column 2. Any ideas why I would want to use either row 3 or column 2? There's a 0 in it, and I have to multiply by each of these numbers, by a 1, by a 0, by a 2, and so if I choose the one that has a 0 in it, well, that's going to throw out 1/3 of my work, just like that, because 0 times anything is just 0. That's why I chose that. But let's try this now. 1 times, that's this one, 1 times negative 1 raised to the power of the position this is. What row is this? This is row 3, column 1. 3 plus 1. In other words, I'm raising negative 1 to the 4th. Thank you. 3 plus 1 is 4. Negative 1 to the 4th power. Times the minor that goes with that. Now, those listening, you have to imagine that I have crossed off the row and the column. Maybe I'll take it off and then undo it. Take off the row and the column. And what is left is my minor. Negative 3, negative 1, 1, negative 1. I'm going to remove that because we have to keep doing different ones. There is the first cofactor. That's my first cofactor, and I'm going to have 3 of them. Plus 0 times, now I'm going to write it out even though this whole thing is just going to be 0, so we won't have to do any math on it. Negative 1 raised to the, now I'm working on this one. What's the row? 3, and what column? 2. 3 plus 2 is 5. I have to raise a negative 1 to the 5th there. And what would the minor be? The minor is this minor determinant, is its full name. You got it. If I cross off the row and column, 5, negative 1, and then, where was I? Row and column. Negative 2, negative 1. Plus, and then I move over to, I'm expanding with this row. 2 times negative 1 to the, figure out the exponent, the power. 3 and 3, 6. It's on row 3, column 3, 6. Negative 1 to the 6. And what is its minor that goes with it? Okay, I'm crossing off the row and the column. 5, negative 3. Negative 2, 1. We have set it up. Now we just need to do the math on this. Well, we know this is just all 0, so that's why we chose that. Now back over here, what is negative 1 to the 4th power? 1. A negative 1 to an even power is going to be 1. What's a negative 1 to an odd power? Negative 1. That's going to be the difference. You're either going to get a 1 or a negative 1. So I have a 1 times 1, which is just 1. So I have 1 times, and then I need to do this determinant. We multiply, what's negative 3 times negative 1? 3, minus, we multiply, what's 1 times negative 1? Negative 1. I'll come back and do that math. Plus 0, plus, now let's come over here, what's negative 1 to the 6th? 1. 1 times 2 is 2. Times this determinant, what's 5 times 1? 5 minus negative 2 times negative 3? 6. We have 5 minus a 6, positive 6. So now let's finish out our math, see if we can get the answer to this. And I have to do the parentheses first. So what would be inside this set of parentheses? 4. 1 times 4 is? 4. Plus 0 plus, what's 5 minus 6? 2 times negative 1? Negative 2 equals, there's our determinant, 2. Good job, Matthew, the right number. All right, there's expanding by cofactors. We found a determinant. And again, we could have chosen any row or any column, and the pattern works the same way, how we do that. If we do elementary row operations on a matrix, how does it affect the matrix? Well, here are the three rules. If I interchange any rows, remember sometimes we interchange rows to get our triangular form, to get that ones going down that diagonal. Well, if we interchange the rows, it will change the sign of the determinant. Rule number 2. If I multiply a row by a constant k, then I have to multiply the determinant by that constant. If I have to multiply a row by 3, then the determinant is going to be multiplied by 3 from the original determinant. And rule number 3, adding a multiple of a row to another row does not change the value of the determinant. And this is the step that we do most of the time when we are putting matrices in triangular form. We add a multiple of one row to another. Has no effect on the determinant. So what's the big deal why we're worrying about these three things here? Because there's a way of getting a determinant that is much easier if your matrix is in triangular form. So here they've given two examples of matrices in triangular form where they haven't even worried whether this diagonal was ones or not. They just made sure we had all zeros. And we can even have triangular form where we have zeros on any half, if you will, any half diagonal. Both of those are triangular forms. All you have to do is multiply that diagonal together. 2 times negative 2 times 6 times negative 5. 2 times negative 2 times 6 times negative 5. The determinant of this is 120. And they did matrix B. They multiplied that diagonal together. And the determinant is 36. If you have a matrix in triangular form, then you can find that determinant by simply multiplying the diagonals together. So we are going to try that idea. It says evaluate this determinant, but first get it in triangular form. Okay, I want to have zeros coming right down here. Well, I happen to be able to use this 2 and make all of these things zeros. I can take negative 2 times row 1 and add it to row 2, and I would cancel out that 2. I can take, whoa, not negative 2. Just a negative times row 1. Negative 2 plus 2 is 0. I could get a negative 2 times row 1. That would give me a negative 4. And add it to row 3. And that would make a 0. And then a negative times row 1 and add it to row 4. And that would make this last one a 0. So I'm going to do that as my first step to get this new matrix. Now that first row I'm not touching. And I am now adding a multiple of one row to another row. So negative 2 plus 2, 0. Negative 1 plus 2, 1. 1 plus 0, 1. Remember, I'm doing negative 1 times this first row. Negative 3 plus 1, negative 2. And when I add a multiple of one row to another row, according to this rule 3 right over here, what change have I made to the determinant? Nothing. Absolutely no change has happened to that determinant. So I'm going to keep going. Now negative 2 times this first row. So negative 4 plus 4, 0. Negative 2 and 5, 3. Let's see, that'd be a positive 2 and 4, 6. Negative 2, isn't that what I'm doing? Negative 6 minus 3 more, negative 9. Then the last one, negative times row 1, and add it to the last, negative 2 plus 2, 0. Negative 1 plus 2, 1. 1 plus 7, 8. Negative 3 plus a negative 3, negative 6. I have my zeros in here. Now I'm going to use this 1 and get the zeros under it. I can go negative 3 times row 2 and add it to this row 3, and I'll get a 0 there. And then just negative times row 2 and add it to row 4, and I'll have a 0 right underneath it. And again, I'm doing a multiple of one row, adding it to another, so I haven't affected my determinant. First row, going to leave it. 2, 1, negative 1, 3. Second row, going to leave. 0, 1, 1, negative 2. Now I'm going to do my negative 3 times row 2, add it to row 3. Negative 3 plus 3, 0. I can keep that one. 0 plus 0 is 0. Negative 3, so negative 3 plus 6, 3. Negative 3 here, 6 minus 9, negative 3. Now negative times row 2 and add it to row 4. 0, 0 makes 0. Negative 1 and 1 makes 0. Negative 1 and 8 makes 7. Negative, let's see, that'd be a 2 minus 6. Negative 4. I have my zeros right under here. Now, I want to get this 7 under that 3 to be a 0. Well, it doesn't work out quite so easily. So what I am going to do here is make this a 1. Now we say, well, multiply by 1/3. Or another way is, and we're going to treat it a little different, I'm going to divide it by 3 or factor out a 3. Here's what I mean by factoring out a 3. Let me just go right to that row. I'm going to factor out a 3. Well, 3 times 0 is still 0. 3 times 0 is still 0. 3 times 1 would be 3. I factored out a 3 sitting in front. 3 times negative 1 would be that negative 3. I'm going to copy the first 2 rows. And we will see here in just a minute why this new little technique of factoring out a number is going to be useful in what we have done here. Now, I can take this 1 and make this 7 a 0. I can take negative 7 times this row 3 and add it to that row 4. So negative 7 times 0, well, 0 plus 0 is still 0. Negative 7 times 0, 0 plus 0 is 0. Negative 7 times this 1, should have been over here, shouldn't I have? Negative 7 plus 7, 0. Negative 7 times this negative 1 is 7 minus 4 gives me what? Seven minus 4 gives me 3. I have made triangular form. Now in the middle of my triangular form, let me back up. Multiplying a row by a constant k multiplies determinant by that same constant k. So right back over here, when I go to find the determinant of this matrix A, I'm going to need to multiply 3 times everything that I'm going to get my determinant, which is that diagonal. 1, 1, 3. You do the math. I can wait. 18. Multiply those together. I get 18. I have found the determinant of this matrix. So this first 3 right here is from this 3 that I had to factor out to make a 1 right here. The rest of it is this diagonal. I multiplied the diagonal together, but I had to multiply it by that 3 that was in front of it. That is a second way of getting the determinant by making it in triangular form first.
Factoring out the 3 on that one messed with the last line as well.
Factoring out a 3 made this row right here, right? Then I took negative 7 times this third row and added it to the fourth row to get my new one down here. Maybe I should have moved this right down here. Okay? That's what I did in order to get that last row. I did 2 steps right there. Zero determinants. Sometimes we get zero determinants, and we can tell if we have a zero determinant without doing any of the math if you notice these rules. If there is any row or column that is all zeros in it, your determinant is going to be a 0. If any 2 rows are identical, your determinant is going to be a 0. Or if one row is a constant multiple of a second row or column. In other words, if I have something like this, 1, 2, 3, 4, there's a row. And then I have another row. Notice this next row is just a multiple of 2. Everything has been multiplied by 2. Or everything is a half as big. Or everything is 5 times as big. Or it's negative 3 times a row. That's what they are saying. If you have any two rows or columns that are like this, you also will get a determinant that is 0. So these are just 3 rules that will give you the answer of 0 without having to do any work, if you notice those 3 rules. They are saying if we have square matrices, and I multiply the matrices together and want to know the determinant of that, it would be the same thing as if I found the individual determinants and multiplied those determinants together. Or they are saying, if I find the inverse of a matrix and find the determinant of the inverse, well, that would be the same thing as 1 divided by the determinant of the original. So if you're asked for the determinant of an inverse, you can go 1 divided by the original determinant, and that will also give you the answer. These are, in a way, some shortcuts. You can go the first 2 methods, or even the first method will find you the determinant. And once you find the determinant, you can do it by that method. Or these are shortcuts to know, hey, it's just going to be 0. Or I know the determinant of the product, or I know the determinant of the inverse. Minor, how did this get out of line? Huh. I thought I jumped awfully quickly back here. This should have been before we did this right over here. We jumped into all the hardest work. It's going to mean it's going to be really easy. This is a review of what we already did. Remember I talked about the minor? We can find determinants by expanding by cofactors. Let me back up. By expanding by cofactors. And cofactors are found, cofactors, right here's the cofactor. It's found by -1 to that power times the minor. And the minor was where we crossed off the row and column. That's what we're doing right here. We missed that little intermediate step, even though I told it to you. They're saying find the minor. Find minor 23. Row 2, column 3. Row 2, column 3. We're referring to that. So if I want the minor, I cross off the row 2 and column 3. 2, -1. 2, -1. And 8, -7. 8, -7. There's the minor, which we go 2 times -7 minus 8 times -1. And minor. It's just the minor determinant. And the cofactor, there's what we were doing a minute ago. The cofactor is when we take -1 raised to the power of the row plus the column times the minor. So let's try this, where they say find a minor and a cofactor. Find minor 32. Minor sub row 3, column 2. Well, that minor, row 3, column 2, tell me what's left if I crossed off row 3 and column 2. Can you tell me without me actually crossing them off? There it is. If I cross off row 3, column 2, 4, -2, 5, 4. There is the minor. Now I just have to do the math on it. And that says 4 times 4, which is 16, minus 5 times -2, which is a -10. And what's 16 minus -10? 26. There's your minor. There's minor sub 32. The minor from row 3, column 2. They want the cofactor sub 12. Well, the cofactor sub 12, I need that -1 in front, raised to, what's 1 plus 2? 1 plus 2. 3, the third power, times the minor that goes with position 12, row 1, column 2. Row 1, column 2. So it's that number 3. Ooh, I need to pull out that number 3 to get my cofactor. 3 cofactor 12 equals 3. So there's row 1, column 2. times negative 1 to the third, 1 plus 2 is 3, times 5, 4, 3, negative 6. So I have 3 times negative 1 to the third. What's negative 1 to the third? Negative 1. What's 3 times negative 1? Negative 3. Times, now I need to do this determinant. What's 5 times negative 6? Negative 30. Minus, it's always minus, what's 3 times 4? 12. So I have negative 3 times, what's negative 30 minus 12? Negative 42. So negative 3 times negative 42. Positive 126. There's our cofactor. Double check for me real quick. Look at example 2 in your book. Did we get the right answers? I want to make sure I don't need to throw in that number on the minor. Did we get the right answers there? Example number 2. You got 26 and 42? Okay, so here's the deal. The cofactor does not include that number. But it does have that negative 1 in front of it. So that negative, whoa, wrong spot. That negative 1 does stay in front of it. And so a negative 1 times a negative 42 is a 42. There we go. You don't put the number in front until you are actually finding the determinant, which is what we did on the next step. Then that number goes in front. All right, I think I am done. You guys can work on this section. So that wasn't so bad.